Professor Belfrost's science class is back.
Hi, welcome back to my class, and thank you for always following up with me. And today, as usual, we will have another discussion on the set of three problems that I prepared for you from my collection of exam papers, past exam papers. So here are the problems. Okay, mathematics, physics, chemistry. Number one, two, three. Please take the screenshot, pause the video, and solve it by yourself first before. Give a try first before play my video again to watch for the discussion solution. Okay. So number one is mathematics. Okay, mathematics is fun actually. Let's give a try. So this is the discussion on the chapter of geometry. Okay, so we are given that the coordinate of P is, okay, let's say this the coordinate of P is A, B, C, and Q will be on 0, 0, C. Okay, this is three dimension. Okay, so this is three dimension, and the coordinate of R, which is the image of the coordinate P, will be, yeah, on the mirror side. Okay, and because the mirror plane is x plus y, it means that it will be on the back of z, the negative plane of z, which is a, b, and minus c. Here, PQ is a perpendicular to the plane x plus y equals 3, so PQ is parallel to the normal of the given plane, meaning that the AI hat plus BZ hat is parallel to I hat plus J hat, which results A equals B. As midpoint of PQ lies in the plane x plus y equals 3, so yeah, we just need to divide the distance, right, of A and B, half half. Okay, so half of A plus half of B equals 3, so A plus B equals 6, and because A and B is the same, then A is 3, B is 6, B is 3 too, while the distance of P from the x-axis is 5, which is given in the passage. Okay, and this is actually the square root of b squared plus c squared. This is very easy, right? This is just Pythagorean theorem. So by noting this, b squared plus c squared equals the 5 squared, which is 25, and c squared equals 25 minus b squared. B is 3, right? 3 squared. So 25 minus 9 equals 16. And we find the value of c by taking a square root of 16, which is 4. Okay, and because PR is actually twice the distance of C, so 2C 2 times 4 is 8. Okay, very easy. Now let's try to solve the physics problem. Okay, so here actually we have to pay attention to conservation of momentum and also elastic collision. Yeah, it's the chapter of momentum. Linear momentum actually. This is quite easy. So yeah, as you have known, the formula of the conservation of momentum can be expressed as shown in the slide. Okay, you can use another term. You can use U. Okay, but I choose to use this term. Yeah, where one refers to the block attached to the spring, one and two refers to the block colliding the spring block system. Also, it's told that the collision is elastic, so you can see at the slide the kinetic energy will not change. The kinetic energy will conserve too. So it will give us v2 apostrophe equals v1 plus v1 apostrophe minus v2. Now we can, using this equation, we have get to uh, create the new equations as shown in the slide. So we have v1 apostrophe now and v2 apostrophe written in terms of m1, m2, v1, v2, and now it is very easy for us to find the needed value. We just need to substitute value, and we find the v1 apostrophe. Okay, the velocity of the first system after collision, it is 4 meter per second, and the second system after velocity is minus 2/3 meter per second. But the time period of mass 2 kilogram, which is the system 1, after attaining the component of system 1 after obtaining the velocity is t equals 2 pi times square root of mk, which is 2 pi times square root of 2 of 2, which is 2 pi second. Okay, therefore the time taken to return to the original position by 2 kilogram mass is just half t, which is half times 2 pi, which is pi seconds. Okay, so we have know the t, we have know the velocity too, then the distance between two blocks can be obtained as follows. So you just need to use the simple formula s equals p times t, which gives us 2/3 times pi, 2/3 times 22/7, which is 2.09 meter. Okay, so please note here that we take the phi to be in absolute value. We don't need the minus sign here, and maybe you'll have to find the answer by yourself why I do this. Okay, this is a thinking part of you. Okay, think, because there is no instant solution in this world. Okay. Okay, now number 3, we have to analyze about what is which one of the compounds or the elements, the compounds, sorry, the compounds given is or are amphoteric oxide. So what is actually amphoteric oxide? I don't know if you have learned this or not in your school, but amphoteric oxide is actually a class of chemical compounds that exhibit both acidic and basic properties. So this kind of oxides can react with both acids and bases depending on the conditions of the reaction. Or in other words, they can act as acids in basic environment and as bases in acidic environments. Okay, so now let's analyze its option. In A we have Cr2O3, BeO, SNO, SnO2. Cr2O3, which is chromium trioxide, this component is amphoteric because it can react with both acids and bases. How about beryllium oxide? It's also amphoteric. How about tin 2 oxide? This is also amphoteric. How about tin 4 oxide? This is also amphoteric. So because all of the components, all of the compounds, I mean, in A are amphoteric, so A are absolutely correct. How about the option B? So option B, we have chromium trioxide. This is amphoteric, as have been discussed in the A. How about the chromium 2 oxide? Chromium 2 oxide is not amphoteric actually, because it tends to act as a basic oxide actually, rather than amphoteric property. Okay. How about tin 2 oxide? This is amphoteric. How about lead 2 oxide? This is also amphoteric, as have been shown in A. But as chromium 2 oxide is not amphoteric, the option B is not absolutely correct. Okay. Now the option C, we have nitrogen 2 oxide. Also, nitrogen 2 oxide or nitric oxide is actually not considered amphoteric, yeah? Because this actually is a neutral oxide. Okay. Now boron oxide. Boron oxide is actually not amphoteric too, because it tends to exhibit acidic properties rather than amphoteric, which can be acidic or basic. Okay. How about lead 2 oxide? Lead 2 oxide is amphoteric, as have been discussed in option A, right? Okay. How about tin 4 oxide? Tin 4 oxide is also amphoteric, as has discussed in the A option. So since NO, nitric oxide, and the boron oxide are not amphoteric, so option C must be incorrect. Okay. Now option D. Let's analyze the last option. Zinc oxide. Zinc oxide is amphoteric because it can react both with acids and bases. Okay. Aluminium oxide or aluminum oxide. Yeah, you can read this. You can read it as aluminium or aluminum. Okay, both is correct actually. This is amphoteric. It can exhibit both acidic and basic properties. Easy, right? How about lead 2 oxide? Lead 2 oxide also amphoteric. Lead 4 oxide also amphoteric. So all the compounds shown in the D option are actually all amphoteric oxides. So based on the analysis that I've given for you before, then we can determine that the correct option are A and D. These two are the options that contain all amphoteric oxides. So we have done with our discussion, and here a little quote for you. So George Bernard Shaw once said, "Progress is impossible without change, and those who cannot change their minds cannot change anything." Okay, so prepare. Always be prepared with any change in your life. Adapt to it and start a new thing every day. Learn new thing. Start adjusting yourself to be better and better, because that's what needed in this competitive work. Okay, so that's for today. Thanks for watching, and here's to-do list. Subscribe, give a like, comment, share this video. I'm sorry if my English pronunciation sometimes not clear enough. I'm not a native English. Okay, so my class will be on Tuesday and Thursday every week. Why I write THUS? THURS actually. Okay? Thursday every week. Keep watching and be thoughtful. Goodbye. See you all.